So throughout, if it ever says evaluate the series, all it wants you to do is add them together. So I think questions 1 and 2 on your homework or something, just add them together. Sorry, I forgot to record. It's common. This right here is not part C, it's part B. Use the mouse to write. There it is. And we are looking at part C really quick. Will the sum of a sequence of even numbers always be even?
Yes.
You add all of the even numbers, will it still be even? Yeah, because you're not going to have that one left over to knock them into the odd range, right? So,
always even.
Always even? Yes. Always even.
Always have an alpha thought, always even.
Sorry, what?
You always have an alpha thought, always even.
Yeah.
Yes.
Well, the sum of sequences of odd numbers will always be odd. No, not always, right? Sometimes?
All the time, they're all odd.
It depends on how many odd numbers there are. If there's an even amount of odds, then you have those two leftover pieces that will combine to make it even, right? So then your answer would be even. But if you have an odd number of odds, the sum would be odd. Okay, moving on. Okay, I want you really quick to read example 4. Sorry, what? Not really that. I do that loud.
No, not forget.
You're going to explain it in words that are good. Yeah. You just did it loud. You're good, Brendan. Example 4. Please read the problem. Make sure you understand the situation. The hardest part was story problems, right? Example. Yeah, so start week 1 they would have to, let's say start the list. So week 1, how much would they have to have in sales in order to make the bonus? 10. And then if they did like the minimum on week 2, they would have to do what in order to earn the bonus at the end? It would have to be 12, and so then it just keeps going up, right? Hey, this is the concept. So a company pays $10,000 bonus to a salesperson at the end of their first 50 weeks. If they make 10 sales in their first week, and then every week from there on out, they improve their sales by 2. So week 1 is 10, and then week 2 would have to be at least 12, and then at least 14, and then at least 16. One salesperson qualified for the bonus with the minimum possible number of sales. So, yay, you get the bonus. I want a bonus. That's a good one.
Yes.
Part A. How many sales did the salesperson make in week 50? Is that asking for the sum, or is that asking for term 50? It's asking for how much is in term 50, right? Now you could take that and add 2 50 times to get how many sales would have to be in the 50 weeks. Sorry, what? Maybe. So the best way to do it to confirm, so Brandon's guessing 110. The best way to confirm is to do what? How would you find the 50th term? What did we do on day 1? We have to do the explicit formula so we can plug it in. So the formula starts, A sub n equals the common difference, in this case, 2n plus, because if you add those together, do we get the 10? Yes. So on week 50, sorry, what? The 2 and the 8, kind of a way to confirm if you did it right, if those 2 added together would equal to 10. Now if I plug in a 50, looks like we're really close, Brandon. It's 108. On week 50, it would have to be 108 sales in order to qualify for this bonus. Just in that 1 week. In 1 week, it would have to get 108 sales to qualify for this bonus. Okay? So, question B. How many sales did the salesperson make in all 50 weeks? Is this a what is term 50 question, or is this a sum question? Now I want to find the add, right? So we have to use the formula. In order for this to work, we need to know A sub 1. What is it? 10. We need to know A sub n, which in this above helped us figure out that part. So, okay, the first term is 10, the last term is 108, and then we need to know N, which is the number of weeks, which is 50. Is that okay finding those three pieces? Are you comfortable with that? And into N is the last term. Yep. S equals the number of terms divided by 2. Do you have to write this as number 2 or could you just write 25? 25 is fine, I don't care. But usually when me and the teacher skip step, I confuse somebody. So I always write everything down. Plus the first term, or times the first term plus the last term. Can you do this one? Go. 2009, I think you're right. 2,950, simply confirmed. Yeah? So, 2,950 sales. That's not even dollars. That's how many sales they're selling toy boats and a little rowboat and 5-year-old. That's how many rowboats they'd have to sell. That's a lot of rowboats. If the salesperson earns a $57 commission per sale, what would their income be at the end of the 50 weeks? This is a slightly trick question, see if you can get it right. If they earn a $57 commission per sale, what would their salary be at the end of the 50 weeks?
When you use times the sum?
Yeah, so the sum is the 2950 multiplied with $57 commission.
That's ridiculous to me.
So an amazing salary, what is it? 100 and what? 3/4 of the 10,000 is 168. 160? Is that? However, did this person get the bonus?
Yes.
Yeah, so we need to add on the bonus. So how much is this kid's salary? $178,150.
That's ridiculous.
Which is why I went into education, so I could teach you that. Sweet. They bought a bigger boat than boat. Cool. Does that make, there's one just like that on the test. It's slightly different scenario, but it's similar. Broken out A, B, C, just like that. Like that. Okay, cool. We actually, maybe we'll get a little bit more done today than we did on Friday, I don't know. Any questions so far? Do you feel like you got it? Okay, this is the capital Greek letter sigma.
Can you just keep continuing with that formula, or no?
For that part?
Yeah, you can just keep continuing down below, can you, or no?
Are you still talking about example 3 or example 4?
Can you use that?
No, you're done with example 4, we can move on.
I know, I'm saying to use that formula, though.
For what?
How many periods or new series or something.
No.
I don't.
Unless you're meshing things together. Okay, this is the capital Greek letter sigma. It's supposed to identify the sum. Now, what lower limit and upper limit mean is kind of confusing. This is the first n value you will plug in. Almost always it starts with n equals 1. If you are writing it yourself, it'll start with n equals 1. However, it is possible that if it's just given to you, it could start at some other number. The upper limit is the last, it's like your eighth of n. But it's not really eighth of n. That's not entirely true. It's just n. Like it's the very last term. So in the previous case, this would have been a 50 because that's the last amount of weeks. And this would have been a 1 because it's starting at week 1 and ending on week 50. Does that sort of make sense? If I start on week 3 and end on week 53, it would be from 3 to 53. Okay?
Basically, in the formula below that, you feel 7 for A.
I'm not there yet, Brandon. What's your name? Then the explicit formula, no, the 207 would not go here. N would go here. Then the explicit formula is just the formula we've been doing for several days. For example, if you had this series, 3 squared plus 4 squared plus 5 squared plus yada 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 108 squared, what is the pattern? I'm taking what? I'm taking a number and I'm squaring it, right? You see that? Really good. So I'm taking a number and I'm squaring it. The very first number they plugged in was what? That's why n equals 30 right here. The very last number they plugged in off the screen is a 108. That's my last number, 108. So that's what the different pieces mean. So first, we're just going to practice writing it in summation notation. And then we're going to pause for a second and let you catch up on some things on your homework. Times what? 50? Which would be a really good stopping spot to catch up on your homework. Now, let's start by writing the explicit formula. On your own, we've been doing it for several days. Write the explicit formula for this sequence. Don't worry about the top number or the bottom number, just write the number that goes with the formula. Arithmetic. Let's backtrack, okay? Hold on a second. So what's the common difference? 4. So 4n plus, what goes here? And then you can check yourself. If you add those together, you get the 7, so you know you did it right. If you plug, how do you know what number goes here? N equals what? What would I have to plug in here in order to get a 7? So what would n have to be in order for this to be a 7? A 1. Remember how I said it's almost always 1? Especially if you're the one that's writing the equation, that will always be n equals 1. Now we need to figure out, remember this is n, we need to figure out how many terms there are in the sequence.
51.
So we just barely did that. Brandon gets us 51, let's take these right. We did that on the previous page. We need to take the 207 and set it equal to the 4n plus 3. And will that tell us what term, that's what n means, what term the 207 is? Yes? So subtract the 3 and divide by 4, 51. So what goes here? 51. And then you're done. That's summation notation.
Okay, seriously?
Seriously. Yes. Okay, let's do that again. Questions? Questions?
I thought, like,
Okay, maybe doing it a second time will help correct it.
I think it's like 4 plus 2. Is that just the first number?
Yeah, it's the common. It's the same explicit formula we've been using for arithmetic from day one. So, or from point 1. So you do a common difference, which would be 4, right? 4 times n. And then what number comes before the 7 if there wasn't one? It would be a 3. Yeah, so you subtract 4. So let's do that one more time. This again is arithmetic. What are we adding every single time? 7. So on your own, start by writing the arithmetic formula right here. The explicit formula right there. So you told me the common difference was 7, so 7n. And then, since we're going up by 7 this way, going to the left, what would you do? Minus 7, or which would be a minus 12, right? Any questions with how you get that part?
No.
Now check yourself. If you plug in a 1, do you get negative 5? Yes, that means n equals 1 goes here. Now the last thing to determine is what? The top number, right? So what do? You take that very last term, you set it equal to your explicit formula, solve for n, and that will tell you how many terms there are in the series. Add the 12, you get 2, and then divide by 7, and equals 40. Very good. So the number that goes up here is. Okay, so let me tell you which ones on the homework you can do at this very moment. And we're going to have you work on homework until lunch, which is only 8 minutes, but it's 8 minutes, so you might as well use your time. On day 3, right now you should be able to do problems 1 and 2. 6 and 8. And okay. So 1, 2, 6, 8, 21, 22, and part of 25, part of 26 maybe. That's about it. So you've got a couple. And anything from day 2 that you haven't finished that you should have finished, but it was the weekend and kind of a big one. So you would freeze this. Pause this. Okay, typo in problem 21 on the homework. Notice how the common difference is 10, and then all of a sudden it jumps to having the common difference of positive 7. So this, get rid of that very last term and make this a 260. And then the common difference will work, and you can do that. So again, 21, 22,
Typo?
or 21. Yep.
So the typo is like what?